My name's Orianna. I'm the CEO and founder of Aquacycl, and welcome to Wastewater Wednesdays. So now we're going to talk a bit about how does our technology, Aquacycl's bioelectrochemical treatment technology, fit into all of the different types of wastewater treatment schemes that we have employed, whether you're at a municipal setting or an industrial setting, even an agricultural setting. Where does BETT fit in? How do we help? So this would be a typical setup, and there's lots of iterations and lots of different specific technologies you can use for this kind of a treatment scheme. But generally speaking, if you want to take a high strength wastewater, say starting with 20,000 parts per million of biological oxygen demand, and you want to get yourself to a point where you can reuse that water for an industrial purpose, on site for irrigation or for your boiler or HVAC system, right? You have to use a combination of technologies to make this happen. So where do we fit in? Well, our goal is not to displace any technology. It's to make sure that whatever you've got already plugged in works better, faster, cheaper, less maintenance, less energy. So we fit into a lot of different places in the scheme. First off, when you're dealing with an anaerobic process, as we mentioned before, anaerobic digesters need a lot of TLC, right? They like to, they operate best when there's a very consistent feedstock, consistent temperature, consistent pH, consistent mixing. And what that doesn't always happen in a production environment, especially if you're manufacturing. You have manufacturing shutdowns, you have holidays, you're changing your product line, right? All of these things can create variability in a digester, so it won't necessarily perform to its best. But if you put in a BETT unit, we can actually help with that. So we'll take the shocks. So what we would do is we'll put a BETT system up ahead of the anaerobic digester. And in this case, our goal is not to remove, completely the biological oxygen demand. It's really just to transition the tough stuff, the different types of difficult compounds that make up biological oxygen demand, into a nice normalized feedstock that the methanogens love to eat. So you put us in front of a digester, and the normalized feedstock that goes into an anaerobic digester, right, is a nice consistent composition of volatile fatty acids, or VFAs. Methanogens love volatile fatty acids. That is their preferred food source. And when there's plenty of CO2 in here, they're actually going to make a whole lot more methane. And so with a normalized feedstock of VFAs that comes from BETT, you can increase your methane production upwards of 30%. We take out the shocks. We ensure this digester consistently is operating at its peak performance. Now, the other thing that we can help complement with an anaerobic digestion system is treating the digestate. So the sludge that gets removed from a digester also has to be treated or dealt with. But you can send that digestate straight to BETT. We'll break it down, we'll reduce the amount of solids that has to be hauled off site, and we get a little bit more energy that can feed right back into your digester for that increased biogas. So now you've got some pre-treated water from your digester. Typically, this will next go to an aerobic treatment method. And that's going to take out a majority now of the remaining BOD, biological oxygen demand. Now, sometimes your production environment may have waste streams that are higher than 20,000 parts per million. Say, 50,000 parts per million. This is not unusual for certain side streams. So if you do have a wastewater concentration that is greater than 50, or anywhere between 20, 50 or higher, and you want to bring in a BETT. So in this case, we'll take that concentrate, we'll remove a majority of the biological oxygen demand, 85 to 90%, and then we'll feed that into your aerobic system so you get even more water back, right, into your process. In addition, because we're taking out the side stream, we're giving you more water, but we can also fit in between the anaerobic digester and the aerobic digester. And the reason we would do that is sometimes the anaerobic digester, even though you're increasing your biogas, you got a good amount of energy recovery here, it may not always take out as much biological oxygen demand as you want to. And that can add some stress onto your aerobic process. So if you put us in, again here, as another treatment method, complementary, we lower that BOD as much as possible. So now that the waste that's coming into your aerobic process, you're going to require less oxygen and therefore less energy to remove the remaining biological oxygen demand. So this can decrease your energy cost significantly, up to 50 to 60%, right? So you're decreasing your energy consumption. You're also decreasing your carbon emissions, because most of your CO2 and greenhouse gas emissions are associated with the energy that's put into running this entire system. And 60% of the cost is usually right here in forcing air into water. Now, once you've removed most of your organic and other compounds, you still have polishing steps that need to happen before you can get to reuse. So from a membrane-based technology, you're also going to be generating another waste stream, which is the concentrate. So this is the really high total dissolved solids. You're going to have also residual biological oxygen demand that has to be treated or dealt with, right? It can't go back necessarily into the process because the salt concentration, the total dissolved solid concentration is so elevated. But that total dissolved solid doesn't actually hurt BETT. We don't remove any of the salts or TDS, but it doesn't impact performance for us. So you can put BETT here also to treat the membrane-based concentrates, removing the BOD and reducing the amount of TDS heavy wastewater that you have to haul outside.